Okay, this video begins our unit on polynomials, functions, and we're first going to talk today about quadratic functions. By this video, you'll know exactly what I expect when you are given a quadratic polynomial and what it is. So first off, since this unit is on polynomials, let's quickly talk about what a polynomial is. Polynomial is a function that is pretty basic. It looks like generic form is this. So you have a term, you have a coefficient, and then you have x raised to a power. You have another coefficient, x raised to 1 power less than that, the previous one. Another coefficient, and an x raised to 2 powers less. So the idea is that a polynomial has several terms. Terms are separated anywhere. Anywhere you see a plus sign or a minus sign, that separates terms. And a polynomial also is known for its degree. Its degree is the highest exponent. Now or highest exponent, I'll put power, highest power. We typically put that first, but it does not necessarily have to be. In standard form, we would like it to be first. Alright, so let me just give you a quick example here. So I have 5x to the 6th minus 2x to the 4th plus 5x minus 8. Now you may notice I skipped several powers, or for example I skipped 5th power, 3rd power, 2nd power, and so forth. And that's completely okay. That just means that there were zeros there. So if I wanted to write out all of it, I'd write out 5x to the 6th plus 0x to the 5th minus 2x to the 4th plus 0x cubed plus 0x squared plus 5x minus 8. So this officially only has 4 terms, but you could write them all out if you want to actually see those other powers, and it has a degree of 6. Now, as we learn more and more this unit, all that information is extremely beneficial. Alright, so now let's quickly talk about the idea that polynomials have zeros and factors. A big rule that we're going to learn is that whatever your degree is how many zeros you have, and in turn that is how many factors you have. Now, that is, of course, if you include complex numbers, which we'll talk more about later. But for right now, I just want you guys to understand that zeros and factors are very, very closely related. For example, if a function has a 0 at x equals 5, that means that one of its factors must be x minus 5. So a 0 is a number that turns you into 0. That is why x minus 5 is a factor, because if I plug in 5, 5 minus 5 is 0. So once again, I could have x equals negative 2, for example. That means that x plus 2 must be a factor of it. Again, what are factors? Go back to regular numbers like, 8. What are the factors of 8? Well, 4 times 2. Why are 4 and 2 factors of 8? Because they multiply to make 8. Well, it's the same kind of idea here. Also, what makes 4 a factor of 8 is that it goes into it evenly with the remainder of, here it comes, 0. So that's why all the factors and zeros are all closely connected. Don't be afraid if you see fractions. For example, x equals 1/3. If that is a 0, then x minus 1/3 would be its factor. 1/3 minus 1/3 is 0. Okay? Don't forget about irrational ones. Don't let these scare you. If the square root of 2 is a factor, then if the square root of 2 is a 0, then its factor would simply be x minus the square root of 2. Not a big deal. Radical 2 minus radical 2 is 0. Watch out for ones that might look like this as well. 3 plus the square root of 5. Now, what's interesting is that we have 2 parts here. This part that's rational, this part that's irrational. Don't worry about it. Still, x minus 3 minus radical 5. If this x right here gets turned into a 3 plus radical 5, I need the 3's to make a 0, and I need the radical 5's to make a 0, which is why I need a negative 3 and a radical 5. And a negative radical 5. Now, one more really important topic here is the fact that irrational zeros always come in pairs. So if radical 2 is a 0, you automatically know that negative radical 2 is a 0 as well. They always come in pairs. If 3 plus radical 5 is a 0, you automatically know that 3 minus radical 5 is a 0. Now notice that then notice that the plus and the minus switches on the radical, not the 3. The 3 still stays 3. So the factors would be x minus radical 2, and this one would be x plus radical 2. This would be x minus 3 minus radical 5. This factor would be x minus 3 plus radical 5. Again, that way when I plug that in for x, the 3's cancel and the radical 5's cancel. But this is a really important concept that's going to come up a lot this unit, and that's that irrational zeros always come in pairs. Always, always, always. So if you know one, you automatically know another when you have those irrational square root zeros. All right, now let's jump ahead and actually talk a little bit more specifically about quadratic functions. We should already know a lot about this, so it should be a little bit of review, but I want to talk about it. First off, a quadratic factor is or quadratic function, has a degree of 2. As long as you have a degree of 2, you are considered to be quadratic. So when you have the general form, ax squared plus bx plus c, the b could be 0, the c could be 0, but the a has to be a non-zero value, or else the x squared goes away, and if the x squared goes away, then your degree is no longer 2. They make a graph called a parabola. I don't think I need to tell anybody that. Now, when we have a quadratic, there are several things that we want to be able to do with it. The first thing we have that we want to be able to do with a quadratic is find its zeros. We've learned a lot about that. You could factor, use the quadratic formula, or complete the square. Obviously, in the graph, here are our zeros right here. That's pretty easy. The other thing we want to know is how does it open? Does it open up or does it open down? Well, that's all based on the a value right here. If a is greater than 0, it opens up. If a is less than 0, it opens down. Pretty easy to understand that as well. Don't worry about when a equals 0, because that can't happen. If a equals 0, you do not have a quadratic because it cancels out your square. All right, what else do we want to know here? The other thing we want to be able to know is its vertex. The vertex is the very, very min or the very, very max, depending if you open up or down. That's called a vertex. And the other thing we want to know here is what we call the axis of symmetry. The axis of symmetry is simply an imaginary line that if you flip the parabola across it, it would mirror onto itself. So the axis of symmetry goes right straight through the vertex. That way when you flip one side over to the other, or left to right or right to left, you get this mirror image. So same thing over here. The axis of symmetry goes straight down the vertex. The axis of symmetry is very easy to find. All you need to know is the vertex. We'll show that later. So those are the major things we want to be able to do, is find the zeros. And remember, if you have zeros, you also have factors. So that's an important part. We want to know how it opens, what the vertex is, and what the axis of symmetry is. All right, now I want to take a look at two quadratics here, and I want to talk about how they're very different but at the same time very similar. So notice we have x squared plus x minus 12, 2x squared plus 2x minus 24. Now how are they similar? Well, first off, g is just f multiplied by 2. For example, if I factor out that 2, I get x squared plus x minus 12. That's what makes them very similar. But I want to show you what the purpose or the power of this 2 does. All right, for example, let's talk about the zeros. The zeros are, well, if I find the factors first by factoring, I get x plus 4 times x minus 3. And I get that over here as well, but be careful, there is that 2 out front there. And this is going to give me two zeros of negative 4 and positive 3. Once again, same thing over here, negative 4 and positive 3. Now I went ahead and actually graphed this for you so you can actually see the negative 4 right here and the positive 3 right here. You can see that this guy also has a negative 4 and a positive 3, but because we multiplied by 2 on the outside of the function, we learned that that's a stretch or a shrink, however you want to look at it. It's a vertical change to the graph. So notice that my vertex changed. Here my vertex was right around this point right here. Now it got stretched or pulled, or however you want to look at it, all the way down to here. So the vertex did change. All right, so I graphed both of them at the same time on this graph right here so you could see the difference between the two. Notice that they both have the exact same zeros, but because of that multiplication of 2, the vertex got stretched way down. So that's an important thing that we're going to talk about. I just want you to understand that you could have two quadratics, or heck, you could have two polynomials that are very similar in terms of having the same zeros, but very, very different in terms of what they look like. So please make sure you keep that in mind. All right, so we kind of want to talk now about the standard form of a quadratic. This is like the Cadillac of forms. This is the most important form. This is actually the preferred form for quadratics, but it's not the most common, to believe it or not, but it is the most preferred. So first off, what is the standard form of a quadratic? It looks like this: a times x minus h squared plus k. Notice the parentheses out front. Now this a is the same a that we saw earlier that we lead off with. But the most important thing here is that the transformations we could actually see. Remember that the k is going to move the vertex or the entire parabola up k, and then the negative h, the fact that it's a minus h, remember, if you remember the transformations, it's going to move it to the right. So the vertex goes from being 0, 0 on a normal parent function of x squared to now the vertex is h comma k. So one important aspect of standard form, why it's so important, is that it allows us to visually see what the vertex is without having to really do any math work. Just got to be careful if it says negative h, that really means that the vertex is at positive h, if that makes sense. Now, one thing that we're going to need to be able to do is convert between general form and standard form and standard form and general form. So there's standard form. One more time, general form is over here, ax squared plus bx plus c, which is probably the more common form, but this is the better form that we want to be in. So what we're going to do now is take a look at a couple examples where we see the different forms and we convert them between the two, and we also look at zeros, vertex, axis of symmetry, all that fun stuff. So here's one that's already in standard form. Okay, now we like standard form, right? Because now I first off could say, hey, what are the zeros? Well, a graph like this, I could clearly tell, what's the vertex? That's what I'm going to do first. I could clearly tell that it was moved up 4 and left 2. So because it was moved up 4 and left 2, I know that the vertex is 2, 4. Left 2. I said left 2. That would be negative 2, 4. Because remember, the form has x minus h. So if I were to write this with a minus sign, I would have to use that double negative there. And that's how you could know that the vertex is at that h value, which is, of course, negative 2 if there's a plus sign. So if you understand the transformation, you should be able to understand where the vertex ends up. Now, that multiplication of 3 is going to change the appearance of it. That's, again, another stretch for that 3. All right, now the other thing we need to be able to do is change it to general form. Going from standard form to general form is very easy. All you got to do is follow algebra. First off, I'm going to do x plus 2 squared. That is x squared plus 4x plus 4. Notice I did that first. If you need to come over here and do some dirty work, please do so. So if you have to come over here and do x plus 2 times x plus 2 to figure out what x plus 2 squared is, go right ahead. Now I'm going to distribute that 3. I get 3x squared plus 12x plus 12. Don't forget about that addition of 4 in the end there. So I get my general form of 3x squared plus 12x plus 16. Now the issue with this form is that you can't look at it and automatically know what the vertex is. For the standard form, you can. So we can convert to general form pretty easy. We can get the vertex pretty easy. What are zeros? Well, this might not be factorable, right? So I think that standard form is actually easier to get zeros. Set it equal to 0. 3 times x plus 2 squared plus 4. Now I'm going to solve. I'm going to subtract 4. Negative 4 equals 3 times x plus 2 squared. Divide by that 3 out in front. Negative 4 thirds equals x plus 2 squared. Take the square root of both sides. I'm immediately going to stop because I cannot have a negative square root, which means there are no real zeros. Now, there are some complex zeros involving I, the imaginary number, but we'll talk about in a later unit. So right now, there are no real zeros. So we covered that. If there's no real zero, there could be no real factors. That's okay. What's the axis of symmetry? Now remember, this is a parabola. I'm just going to draw it real loose. This is a parabola that's opening up. How do I know it's opening up? Because my a value is a positive 3. The vertex is at negative 2, 4, and the axis of symmetry runs right through that vertex. The axis of symmetry is a vertical line at x equals negative 2. Again, I knew that because that was the x-coordinate of the vertex. So since the axis of symmetry is a vertical line that goes right through the vertex, the only option for the axis of symmetry could be x equals negative 2. All right, let's take a look at another example. This one is already in general form. So the first thing we might want to do to find the vertex is to convert it to standard form. Now, To convert to standard form, it's a little different. I'm going to complete the square, but I'm not solving. I'm completing the square to get it to standard form. Now, let me explain how to do this. This is obviously a little bit more complicated than going from standard to general, but if you know how to complete the square, this should not be bad. First thing I want is a 1 in front of that x squared, which I already have, which is awesome. So I want the 8x, or the x squared and the 8x. The minus 12, I'm going to put way over here. I want to get it the heck out of the way. I'm not moving it to the other side because I'm not solving. Keep that in mind. All right, now I'm going to take my half number. Half of 8 is 4. That's going to be an important number. And I'm going to square that, so I'm going to add 16. Now, the problem is that I added 16. I can't just add 16, because that's obviously going to change the function. But as long as I also subtract 16 at the same time, again, I'm on the same side. So if I add 16, I also have to subtract 16 to the same side. So I'm essentially adding 0. So I'm adding 16, but I'm subtracting 16 at the same time. So technically I'm doing nothing, but it needs to be done. That's going to give me x plus 4 squared. That's what creates this guy right here, x squared. There's your 4x, and 4x is the 8x in the middle, and then 4 squared is 16. But over here I have to combine these two guys together to get negative 28. And that's it. I'm in standard form. Look how easy this is. My a value right out front here is a 1. You don't have to write it, but it's there. My vertex is going to be left 4. So my vertex would be negative 4, comma negative 28. Now I know my axis of symmetry. The axis of symmetry goes right through that vertex. My axis of symmetry would be x equals negative 4. Very, very simple. Okay, now, what are the zeros? You could find zeros by factoring. I'm going to actually do a couple different things. I'm going to try to factor this. Let's see here. If I could factor that original one, it would be x and x. Let's see here. 6 and 2 maybe. Negative 6 and negative 2. Well, that's not going to work. If I add, it doesn't appear that this is going to work because I need that to be a negative 12, and that's going to give me a negative 12, but a negative 6 and a 2 isn't going to give me an 8. And if I switch it around and make it a negative 6 and a positive 6 and a negative 2, that's not going to give me an 8 either. So it doesn't appear it can be factored. So this is why, again, I'm just trying to show you guys that I think standard form is easier to solve. So in standard form, I'm just going to set the function equal to 0. And I'm going to go ahead and add the 28 to both sides. And now I'm going to go ahead and square root both sides. And when you create the square root, you got to put a plus or minus. Now, the square root of 28 is 4 times 7. And I need to be able to reduce this. And since 4 is a perfect square root, the square root of 4 is 2. So I get plus or minus 2 root 7 equals x plus 4. Now I got to subtract 4 from both sides, so I get x equals negative 4 plus or minus 2 radical 7. Now notice how I put the negative 4 out in front. That's just the standard way that we like to look at it. So just please keep that in mind. And now that I got some zeros, I could also write my factors. So my factors would be x plus 4 minus 2 radical 7, and then x plus 4 plus 2 radical 7. Now remember, they always come in pairs, right? I told you that if you have one square root, you're going to have another one. That's why there's 2 of them. Why do I have a plus 4? That way when I plug in the negative 4, it cancels out. One of them is going to be a positive 2 radical 7, so that's why over here I needed a negative 2 radical 7. The other one's a negative 2 radical 7, so I need a positive 2 radical 7 to get them to cancel. So hopefully that all made a lot of sense. All right, let's do one last one here. This one's going to be a little bit tougher because it's got a 2 in front there. So first, let's go ahead and convert this one to standard form. Okay, here's what I'm going to do first. I'm going to write the 2x squared plus 8x here. I'm going to put the plus 7 all the way over here. Now, I'm being a little bit dramatic how far I'm putting it away, but I just want it out of the way. I'm not moving it to the other side because I'm not solving. All right, now I'm going to factor out that 2, and that gives me x squared plus 4x. Leave some space here. Again, that plus 7's to the other side. Just moving it all the way over. All right, now my half number here, now that I got that 1 in front of the x squared there, my half number is 2. 2 squared is 4, so I'm going to add 4. Now, I can't just add 4 to one side, but you got to be extra careful here. I'm not adding 4. I wrote plus 4, but I'm really adding 8 because when I distribute, I get 2x squared. I get 8x, which is all things that I needed, but I get 2 times 4 here, which is 8. So I'm really adding 8. So I can't just add 8 unless I also subtract 8 to balance it out. So please keep that in mind. Where did that 8 come from? 2 times 4 is 8. Because I had that 2 on the outside here, and then I can't just add 8 without subtracting 8. That way I technically am adding 0. Okay, so this is going to get me 2 times x plus 2 squared. Let me just run through that real quick to you. Here's that 2 right here. X squared is x squared. A 2x and a 2x makes the 4x when I square, and then 2 times 2 is 4, and then minus 1. So now everything should make beautiful, complete sense. I hope that works. So now I could clearly see that my vertex is at -2, -1, because I went left 2, down 1. And I know this probably is going to open up because I got a positive 2 there. My a value is positive. Let's find the zeros. Once again, I don't think you can factor that. So it's much easier to use standard form to find zeros. Set it equal to 0. Now watch this. Okay. Now this is going to be a little bit of math work, but you guys shouldn't like math here. So I'm going to add 1. So I get 1 equals 2x plus 2 squared. I'm going to divide by 2, so I get 1/2 equals x plus 2 squared. Take a square root of both sides. Now let's see here. The square root of 1 is 1, divided by the square root of 2, plus or minus. Now again, how did I get this? Well, the square root of 1 on top is a plain old 1, square root of 2 on the bottom I don't know, and this equals x plus 2. Now one more change I'm going to make here before I move this over is I don't like square roots in the bottom, so I'm going to multiply the top and the bottom by radical 2. That gives me radical 2 over 2. Still don't forget the plus minus. One more time, all I did was multiply the top by radical 2 and the bottom to rationalize the denominator. And this equals x plus 2. And finally, I'm going to subtract 2, so I'm going to put that in front. -2 plus or minus the square root of 2 over 2 equals x. So there's my zeros. -2 plus or minus the square root of 2 over 2. What are the factors? Now this is going to be a little bit ugly, but it's okay. Ugly is not bad. X plus 2, y plus 2 to get rid of that -2, minus the square root of 2 over 2, times the other factor would be x plus 2 plus the square root of 2 over 2. Again, I promise you, irrational square root zeros always come in pairs, a positive and a negative. So hopefully that video made a lot of sense in terms of how to convert between standard form and general form, how to solve for zeros. I think it's easier with standard form. Hopefully you'll slowly be convinced of that. Now I want you also to notice I did this entire video without the use of a calculator, so you need to be able to do this without a calculator. Alright, that's it for the first section. Hope you watched it. Hope you took notes. See you in class.